All right, today we're going to talk about square root functions and their graphs, and then we'll get into some cube root functions as well. So first of all, you know that you could have y equals the square root of x. That would be the parent function. But you also could write it as y equals x to the 1/2. So it's important for you to realize that no matter which way it's written, you're going to graph it exactly the same way. So anytime you don't know how to graph something, the first thing you want to do is, of course, do an XY table. So XY. So if I'm going to pick values of X, I want to pick something that's going to make my life easy. So I'm going to pick something that's going to be a perfect square. So maybe I'll pick 4. And if I plug 4 in, I'll get 2. Or I'll pick 1. And if I plug 1 in, I'll get 1. Or 0, and if I plug 0 in, I'll get 0. What about -1? Can I plug -1 in? Well, if I have the square root of -1, that's going to put us into imaginary numbers, and of course we are not doing imaginary numbers, so this here will not have any negative numbers. So if I were to plot this, I would go 0, 0, I'd go 1, 1, I'd go 4, 2, 1, 2, 3, 4, 1, 2. And you can see that my graph is going to, whoops, I missed. See, my graph is going to look like this. Pretend I went through that point. I just missed a little bit. All right, so I kind of call this the eyebrow graph because it kind of just goes up and over. Let's take a look at some shifting. So now this +2 is going to be my vertical shift. It's going to be the same thing as when we did all the other functions. So once again, I'm going to put an X here because this is kind of my starting point. So if it was 0, 0, I would start here. And if I kind of, again, now that I've done my shift, if I kind of ignore my shift, I'm just going to graph this function right here, but I'm going to graph it from my shifted point. So from this point, I'm going to go over 1, up 1, and I'm going to go over 4, 1, 2, 3, 4, up 2, and then I'm just going to draw my little eyebrow graph. Now, the reason that I had crossed this out is that very often you will see it written like this instead of the first one because you want to make sure that 2 is not underneath the radical. But either way it is written, it is still going to be your vertical shift. All right, let's take a look at a horizontal shift. So if you remember from all the other functions we talked about, your horizontal shift is going to be next to the x, so it's going to be underneath your radical, and it's going to be the opposite sign. So this is going to give me a shift horizontally to -2. So it's like my starting point is now going to be right here. But once again, now that I've taken care of that shift, I can kind of ignore it, and I'm just going to graph my parent function from this shifted point. So I'm going to go over 1, up 1. I'm going to go over 4, 1, 2, 3, 4, up 2. And I could probably go over 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. I can fit that one in here. Usually I can't. And then this would here would be my graph. And both shifts, right? So now I'm going to have a vertical shift of -3, a horizontal shift of +2. So my starting point would be over 2, down 3, 1, 2, 3. And then once again from this point, I can go over 1, up 1, and over 4, 1, 2, 3, 4, up 2, and then just graph my function like that. So let's talk about flips and reflections. So now, if you remember, I always called this a y multiplier because what this is going to do is it's going to take all of your y's and multiply it by whatever's there. And now in this time, what's there is a negative sign. So normally I would go 0, 0. Well, I'm still going to do that because there's no such thing as -0. Normally I would go over 1, up 1, but now because of this y multiplier, when I put in a positive 1, I'm going to get out a negative 1. And I'm going to go over 4, 1, 2, 3, 4, but now I'm going to get out a negative 2. So now this is going to create a flip over the x-axis. Now this one here is going to be the same thing. I'm going to have, let me erase this. I'm going to have a vertical shift of +5, a horizontal shift of -4. So 1, 2, 3, 4, 1, 2, 3, 4, 5. My starting point is going to be here. So I've taken care of my shift. So now I'm going to graph y equals -square-root of x because I've already taken care of my shift. So once again, if I go over 1, I'm going to go down 1. And if I go over 4, 1, 2, 3, 4, I'm going to go down 2. And I could do 9 and -3, but you get the idea. Oops, this has to stop here. Okay. Now here I have a negative underneath my radical. So now if you think about an XY table, if you think about, well, what values could I input? Well, I certainly could input 0 because -0 is still just going to be 0. But now I can't put in 1 because I'd have a -1 under here. But I could put in -1. So now I'd have -1, so I'd get out a +1. And I could put in -4, because if I put in -4, I'd have -4, which is a +4, so I'd get out 2. So when I have this negative, I have to put in negative x values. So here I would have 0, 0. I'd have -1, 1. I have -4, 1, 2, 3, 4, and +2, 1, 2. So now I'm going to have a flip over the y-axis. Now this one's a little bit tricky. So this is one case that you really have to kind of pay attention to, because when you have a negative underneath the radical like this and you've got some addition subtraction, you have to pull that negative out in order to get the correct shift. So you have to pull that negative out because it has to apply to everything under the radical. So this is really going to be a shift of 4 to the right. 1, 2, 3, 4. So here I'm going to have 4 to the right, but now that I've taken care of that shift, I'm still going to graph just simply this like we did before. So I have to put in a -1. So from here, I'm going to go -1, but I'll get out 1. And I'll go -4, 1, 2, 3, 4, up 2. And it'll look like that. So put a star next to this in your notes, because this is definitely something that people forget, that when you have some addition, subtraction, and a negative, you have to pull that negative out. The negative has to apply to everything underneath the radical. And if you put this into your calculator like you see it, you'll see that it will give you this shift here. All right, now let's get crazy. Now let's have a negative underneath the radical and a negative out front. So now, again, let's think about this. 0, 0 is still going to be here, right? That doesn't really get affected. But I have to put in a -1 in order to get this radical. So I'm going to put in a negative x. But if I put in a negative x, I'm going to get out a 1, but then I have this negative, so I'm going to get a -1. And same thing here. I'm going to put in a -4, 1, 2, 3, 4, but I'm going to get out a -2 because it's got that y multiplier in front. And so now here I'm going to have both flips. And now let's talk about cube root functions and their graphs. So now, once again, let's just talk about the parent function. Again, when we don't know anything about it, let's start with an XY table and let's pick some values of x and see what happens. So 0, 0, of course, is always a good place to start. if I put in 1, I'm going to get out 1. But now I'm not going to put in 4 because I want a cube. So I'm going to put in 8 because I want to talk about perfect cubes. And I'll get out a 2. But now because this is an odd root, I can put in -1 and I'll get out a -1. And I can put in a -8 and I'm going to get out a -2. So now I can plot both positive and negative numbers. So here I'm going to have 0, 0. I'm going to have positive 1, 1. -1, -1. I'm going to have -8, 2. Whoops, sorry, -2. And +8, +2. So this is going to be what I call kind of like the S curve. This is what your cube root graph will look like. You can see it kind of looks like your cubic function graph turned on its side. And all your shifting is done exactly like anything else. So this here is going to be your vertical shift down 5. 1, 2, 3, 4, 5. So this is going to kind of be your center point. From this point, you can go over 1, up 1. You can go -1, -1. You can go over 8, up 2. Or -8, down 2. So it's just basically going to take your whole function and just shift it down 5. And your horizontal shift, again, is going to be very similar, where now you're going to take your starting point and you are going to put it on a +2. And so from this point, I can go over 1, up 1. I can go -1, -1. I could go over 8, up 2, but I'm going to run out of room. I'd be over there somewhere. And I can go 1, 2, 3, 4, 5, 6, 7, 8, and down 2. And this would be my graph right here. So you're just going to plot whatever points fit on your graph. And both shifts, right? This is going to be a horizontal shift to the right. To the left, -3, and then up 4. So it's as if you just took this function and put that starting point at -3, 4. And reflections. So once again, remember I call this a y multiplier. So it's going to take all of my y's and it's going to multiply it by -1. So 0, 0 would still be my starting point. Normally I'd go over 1, up 1, but now I'm going to go over 1, down 1. Normally I'd go over 8, up 2, but I'd go over 8, down 2. And normally I'd go -1, -1, but now I'm going to go -1, +1, and -8, +2. So you see it's just going to kind of flip this around. Whoops, I missed, but you get the idea. It's hard to write with the mouse. And if we have a negative underneath the radical, let's think about what's going to happen on this one. So now, well, just like before, I could still do 0, 0. If I input a +1, now I can still get out a -1. That's not a problem because this would become 1 and then it become -1, which gives me -1. Or if I put in a -1, I'll get out a +1. Or I could put in a +8 and I'll get out a -2. Or I could put in a -8 and I'm going to get out a +2. So I'll start at 0, 0. I'll get 1, -1. I'll get 8, -2. -1, 1. -8, 2. So what you're going to notice is that both of these functions actually look exactly the same. So whether you have the negative outside the radical or inside the radical, they are going to look exactly the same. And then if you have both negatives, let's think about what's going to happen there. It's kind of interesting. So now let's again talk about a little XY table. I'd still have 0, 0. If I put in a -1, this would be a +1, and then I'd get out a -1. If I put in a +1, this would become -1. I'd get out a -1, but then this negative would make it positive. So you can see what's happening is that if I have the two negatives, I'm just going to have my original function as if there were no negatives in there at all. So it's just going to be my normal cube root function. All right, so let's take a look at some stretches. So here we have a square root. It's going to have a shift of +2, +3. So we are going to do +2, +3. So +2, +3 right here. And then normally I would go over 1, up 1, but here I'd go over 1, up 2. And normally I'd go over 4, up 2, but now I'm going to go over 4, up 4. 1, 2, 3, 4. So you see it's just going to kind of stretch this graph a bit. And the same thing for a cube root. Okay, so again, here I have a shift of -3, -2. So -3, -2. This would be my starting point. Normally I'd go over 1, up 1, but because I have this y multiplier, I'm going to go over 1, up a half. I'm going to go -1 down a half. Normally I'd go over 8, up 2, but now I'm going to go over 8, up 1. 1, 2, 3, 4, 5, 6, 7, 8, up 1. And I can go -8 down 1, but I'm going to run out of room here. So this would just be the function like this. So if you have any questions, let me know.